Hello and welcome to another video in the Reigate Maths series for the A-Level Maths. This video is focusing on the composite functions topic from Functions and Graphs. Now, the idea of composite functions is very easy to get your head around. Even easier if you understand the meaning of the word composite. Defined as a thing made up of several parts or elements, or combining to make one thing. A composite function is what happens when we take two functions or more and stick them together to create one single function. So let's have a look at how this works. So we have two functions here. We've got f of x equals x squared and g of x is 3x plus 2. Let's not start sticking them together yet. Let's just do some basic calculation. F of 1. 1 squared is 1. F of 2. 2 squared is 4. Should be happy so far. G of 4 is 3 times 4 plus 2, which is 14. G of 1 is 3 times 1 plus 2, which is 5. Why did I choose 4 and 1 here? Well, we can see that 4 is the same as f of 2. So g of f of 2 is the same here. 1 is the same as f of 1. More commonly, we will write these without the brackets. So in fact, instead of just doing f of 1, then g of 1, we've actually done gf of 1. But notice the order. We did f first, then g. The order goes from right to left. But what if we do it the other way round? What about if we think of, we've done gf of 2, let's think about fg of 2. Well, this is f of g of 2. If we put 2 in here, we get 8. So there's f of 8, which is 64. This is not 14. Hopefully I don't have to tell you that. But we can see that in this case, fg of 2 is not the same as gf of 2. And it's not just this case, it's the majority of cases that this idea is true, that fg is not the same as gf. Obviously there are going to be cases where it is true, but in general it's not. So what about finding fg of x? Well, this is f of g of x. So what we're going to do is we're going to take the x part in f and we're going to replace it with g of x. So it's g of x all squared, because f of x, if you remember, was x squared. G of x was 3x plus 2. So fg of x is 3x plus 2 all squared. And you could expand that if you wanted to. If we do it the other way round, gf of x, this is g of f. F was x squared. This is 3x squared plus 2. Obviously there are going to be some similarities between the two functions. There's a 3 and a times by 3 and a plus 2, and there's a squared. that's obviously going to happen because they're the same two functions that we're putting together. But you can see the final result, very, very different. Okay, so here's an example. If you have a go, pause the video, and then come back and we'll go through the answer. So fg of x, we can see, we're going to put g into f. So this is 2x minus 1 square rooted. Now this f squared may have confused some of you, but some of you may have figured it out. This is just the same as ff of x, which is the square root of the square root. So this is x to the quarter. Solving fg of x equals x, well, we know what fg of x is. So it's a case of setting them equal to each other and solving it. So here we get 2x minus 1 equals x squared. X squared minus 2x plus 1 equals 0. X minus 1 squared, x equals 1. Now we do need to check with this that it works for the domain of this function. When x is 1 here, we get 1 as our answer, which we can put into this. So that's kind of something a little iffy that you might have to check with these questions, but on the whole, not really. And that's kind of it for composite functions. Yes, you do have to be wary of the range and domain. I don't think it's something you'll be asked to do, but I'll go through an example using this example here just to kind of get an idea in there. So let's have a look at, well, we know fg of x is the square root of 2x minus 1. Now the domain of g is x is a real number, but we know that we can't put minus numbers into here. So we're already having to change this domain for our new composite function. So we need to think, right, the domain is that x has to be greater than or equal to a half. Because if x is a half, then underneath is 0. Anything bigger, it's bigger than 0, so that works. The range is fg of x is greater than or equal to 0, because that's the type of number we're going to go out. Well, what happens if we do it the other way round? gf of x. Oops. So very quickly we get 2 root x minus 1. So we have to think about now the domain. So the domain is the domain of f. But it's not always going to be that case. It's not always the domain of the inside one. We saw that wasn't the case here. So it's on the whole just looking at the new function that you get and figuring it out from there, and then checking to see if it works in the above. So now we can see the range, if this bit is greater than or equal to 0, that means this whole thing has got to be greater than or equal to minus 1. And that's kind of range and domain of composite functions. It's effectively just figure out the new function and go from there. It's not always going to be that simple, but it's nice when it is. But that's kind of it for composite functions. Thank you for watching.